Okay, so number 20, or it's number 1 on your Scantron. So it says nearest neighbor. So it doesn't say repetitive nearest neighbor, huh? It's just nearest neighbor. Just nearest neighbor. So that means that I just start. And where are we starting? Does it say at the top? Up there, you can barely see it. Starts and ends at Memphis, huh? Starts and ends at Memphis. Did you notice that up in the writing at the top? So start and end at Memphis. Well, and you can see it on the answers, huh? They all start and end at Memphis. So when it just says nearest neighbor, that's all you do just one time, start and end at Memphis. So here we go. I'm going to start at Memphis. What's the nearest neighbor to Memphis? Lowest number is 371, which is, what is that? Atlanta. So it's going to go Memphis to Atlanta. Now I'm going to write it out first off. So Memphis, here, I'll write it over here maybe. So Memphis to Atlanta. Okay. See how I came up with that first step? Everybody good there? I'm just looking at Memphis and how far every city is from Memphis. The closest one is Atlanta. So now from Atlanta, let's go to the Atlanta. Look at all the numbers, how far the cities are from Atlanta. Who's the closest one to Atlanta? Well, Memphis, but we can't go backwards. So Houston, I guess, 389. Houston. Okay, now I'm at Houston. Let's look at the numbers for Houston. Closest one is for sure Dallas, 243. You don't even need to write down the numbers because we're not going to add them up and compare them. We're just doing it once, huh? Dallas, so that's 4 of them. How many cities do we have? 1, 2, 3, 4, there's 6. Okay, 2 more. So from Dallas now, who's the closest? Well, Houston, but we can't go backwards. Followed by Memphis. We can't go back to Memphis. Kansas City would be next, right? Kansas City. And now, once I get to Kansas City, I've got 1, 2, 3, 4, 5. I got 5. I got all but one city, right? When you only have one city left, don't bother with the chart. Just go to that city and go home. That's what, Denver? Yeah, last city is Denver. And then back home to Memphis. Okay. So which answer? Now remember, the answer can be forward or backwards. So watch out. Don't get tricked by that. They can do that same loop. Forward's a loop, really, right? So it can be forward or backward. So Memphis, Atlanta, Houston. C's looking good. Memphis, Atlanta, Houston. No. Oh, yeah, Dallas, Kansas City, Denver, Memphis. That's it. So it's answer C, huh? We good there? I'll move on. Stop me if you have questions. Moving on. 21, cheapest link. Now that's a little harder. Cheapest link. Remember what you do with that. You grab the cheapest link anywhere. So you just start with the lowest number anywhere in the entire chart. What's the lowest number you see anywhere in that chart? 243, right? And it might be helpful to scratch out half the chart because all the numbers are twice, right? It's from Memphis to Atlanta and Atlanta to Memphis, and kind of confusing to have them twice. So I think for cheapest link, it's helpful to cross off half the list. Okay, here we go. Cheapest links, just start with the lowest. Remember the 2 no-nos? All right, 2 no-nos. What are you not supposed to do? Don't close a loop too early, meaning with less than all the cities, right? Don't do that. And number 2, don't have 3 roads hit one city. That's the other no-no, right? You don't want 3 roads hitting one city because they just have 2. And then you don't want to close the loop too early. So here we go. So lowest number in the chart is that 243. So that's from Houston to Dallas. I'll go. I remember, and I make a little connection map as I go. Doesn't matter what order, you can do vertical, sideways, whatever, but it'll help you to keep track of it. Houston to Dallas, and you don't have to write down the numbers. The only time you have to write down the numbers is when that repetitive nearest neighbor, right? Because you got to total them all and pick the lowest. Don't have to do that for normal nearest neighbor or for cheapest link. Okay, now what's the next lowest number in the entire chart? Is it 371? I think it's 371, right? Am I missing any? 371. That goes from Memphis to Atlanta. I'll just write it down right here. Memphis to Atlanta. Okay, next lowest number. Just keep picking the cheapest link anywhere. Notice I didn't start from Memphis, did I? Everybody see the difference on cheapest link? Cheapest link doesn't start from one fixed city like nearest neighbor does and repetitive nearest neighbor, right? Those start one place and then next and next, next. Whereas cheapest link looks at everything, right? Yeah.
Remind me why you crossed out the...
Yeah, because all the numbers are doubled. They're all listed twice. Yeah, and I don't want to get confused like redoubling a number, right? Like Dallas, this is Dallas to Atlanta, and this is also Dallas to Atlanta, you know? So they're all listed twice. So for cheapest link, I think it's helpful to get rid of those other ones. You don't have to. Okay, let's keep going. So what's the next number? Is it 452? No, 451? Yeah, 451. What's that? That's Memphis to Kansas City. Okay, now I've already got Memphis right here. So that's, I didn't make my map very nice. Let me move this up. Houston to Dallas, I'll move that up. And I don't have any room. H to Dallas. So Memphis to, what is it? Memphis to KC. So Memphis, I'll just move it over here. Memphis to KC. All right, that's the next number. Memphis to KC. It's eventually going to make a big loop. In fact, well, I got to keep going. What's the next number? 452. That's Memphis to Dallas. Can I do that? Can I go Memphis to Dallas? No, that's 3 lines hitting Memphis. Everybody see that? See why that's a no-no? And I'm gonna cross off the 452, so I know I've looked at it, and move up the line to the next number. Does everybody see that step there? Is everybody okay with that? I cannot make the Memphis to Dallas connection. See, that's why you got to be making this little connection map as you go for cheapest link. Because then you see there's 3 cities hitting Memphis. We can't have that. Remember, you're going to go into each city once and out of it once when you make your loop, not 3 times. So can't do that one. Keep going. So what's next? Is it 489? Yeah, I don't see any lower. So 489, can I do that one? Kansas City to Dallas. Yeah, Kansas City to Dallas. That looks good. Hey, at this point, everything's connected, and I'm only missing one city. Do you notice that? What's the city I'm missing? So Denver again? Denver, yes, Denver. The 2 open ends of the chain have to hit Denver. Then done. Right? What else could happen? You with me? Now that the whole chain's connected, other than the one city. I had to keep going to get the chain connected here. But now that the whole chain's connected, except for one city, what other options are there? Those 2 loose ends have to hit Denver, don't they? What 2 loose ends? So I'll put Denver here. This end and Atlanta. Right? Those 2 loose ends have to hit Denver. I don't even need to look at the numbers. That's the only way to complete that loop, right? So there's the loop. Now I have to rewrite it. That funny looking loop I just made. You've got to rewrite it starting with Memphis, because that's the way the answers are all written out. Right? On number 21. So write this loop starting with Memphis. So Memphis, Atlanta, Denver. Let me write it up here, I guess. Memphis, Atlanta, Denver. Everybody see what I'm doing? I'm just going Memphis, just following the chain's link. Memphis, Atlanta, follow it around. Denver, next Houston, next Dallas, next KC, and then back to Memphis. Now, you can run that forward or backward in the answer. So let's look. Memphis, Atlanta, Houston, no, Memphis, Atlanta, Denver. Memphis, Atlanta, Denver, yeah. Denver, Houston, yeah. Dallas, yeah. Kansas City, Memphis. There it is. It's C again, huh? It's option C again. Is that okay? Does everybody see how I made that link up thing? And you see how I knew to save time? Part of this issue is having some ways to save time, so you have enough time to get this test done well. It's kind of a longer test. There's some ways to save time though, right? Once I had everything linked up with just one city left, all the methods, when you have everything linked up with just one city left, don't mess around. Just connect to that city, make your loop, and find your answer and move on. Is that good? And everybody okay with how I rewrote it? Once I had it all linked, then I started with Memphis and just traced it out. And remember to look forward and backward for your answer. Any questions on that? What is optimal? Optimal just means best, right? So when they say here optimal, they mean, hey, which one of these is best? This is the time where I would just kind of freelance it. Remember that none of these methods necessarily give you the best answer. Do you remember that? None of them are optimal. So what that means is do your own thing. Is that making sense? Just say, hey, look, let's just be smart about this. What's going to be the cheapest way to do this? Well, having said that, I don't know. I don't know. One, 2, 9, 4. 1, 2. I don't know. We could just add these up. We can just add these up right here. Yeah, I don't have a good way to do this. A, C, D, B, A. So I wouldn't add them up on the other ones because it might not be the right answer. But on the optimal, I'm just going to try it that way. So A to C is 4. Well, sorry guys, I'm hedging around. There's a longer way to do this. We just don't have time for that. So I'm just going to look at the map here. So one, maybe the 1, the 2. I don't know. I don't know. What's the optimal way to do this one? I guess we got to add them up. I just don't want to waste all that time. All right, A to C. I'm just going to add them up. So this one is A to C to D, so I'm just going to add the numbers. It's A to C is 4, C to D is 1, and D to B is 8, and B back to A is 9. That's 10, 22. That road's 22. This one, A to B, is 9. B to D is 8. D to C is 1. And C to A, C back to A is 4. 10, 22. Same thing. This one, A to B to C. So A to B is 9. To C is 2. A to B to C, to D to A. 1, and A is 5. Ooh, that's better, 17, huh? Next, A to D to B. A to D is 5, to B is 8, to C and A, to C is 2, to A is 4, 10, 19. Okay, so the 17, it looks like the C looks like the best answer. Is that right? Did we get that one right? Mm-hmm. Yeah, so the optimal one's a little fishy. That's the only one. What I'm trying to do to save time, there's an official method called the brute force method where you list out every possibility. That's how you would technically have to really, what do I mean? Well, you start at A, for example, and then you have all the ways of mixing up B, C, D, and then go back to A. Do you know what I mean? So what are all the ways? B, C, D, B, D, C. Right? You're always going to start at A and end at A, right? So B, C, D, D, C, and then start with C, B, D, D, B, and then start at D, B, C, C, B. And these all start and end with A. So there they are. That's every possible trip. And you got to just add them all up and find the lowest one. That's how you would really be sure that you've got the best answer, optimal. Remember, the computers take forever when there are a lot of cities. Remember how we talked about that? It gets really big. So I wouldn't do all that work. You don't have time for all that. I would just add these up on the optimal. Now, don't get the idea, please, I don't want to mislead you. Don't get the idea you can just add these up and pick the lowest. That won't work for the other ones that are not optimal. That's how I've had a lot of students, not a lot, but a few students in the past get really messed up on this exam. That won't work. Why not? Because it's not saying pick the lowest, which it is here. That's what optimal means, right? Optimal's best. But on these other ones, it's saying do a certain method. It might not be the lowest, right? Repetitive nearest neighbor, cheapest link, nearest neighbor, whatever. It's not necessarily the lowest. Do you guys all catch me on that? That's the mistake I've had students make in the past. Look, Mr. Tarrant, I bombed this test, and I go, what'd you do? And I remember this one guy telling me, well, I just added these up. And this one was lowest, so I took it. I was like, well, it doesn't say pick lowest. It says do the nearest neighbor method or whatever method, which will not necessarily be the lowest. There might be one lower. Remember, these methods aren't perfect. The only time you can do the add up, take the best, one more time, only time you can do the add up, take the best is on the one they say optimal. Optimal means best. Then yeah, just add them up, take the best. Is that good? The other ones don't do that. You got to do the actual method. It might not be the best one on that. All right, good. So we'll move on then, if that's okay. Tomorrow. Okay, so number 30. Hamilton circuits, number of circuits. Okay, that was the formula, what was it, n minus 1 factorial? Yeah. Right, you want to have those formulas on your the number of circuits is that, and the number of edges was, what is it, n? Yeah, is that what it was? Okay, yeah, so make sure you have those two formulas. Thank you. Circuits and edges. Okay, this one's circuits. So plug, now it says 100 vertices. So that means plug in 100. 100 minus 1 factorial. 99, which is 99 factorial. Everybody good so far? I just took the n minus 1 formula, plugged in 100, because that's the n, number of vertices. 100 minus 1, 99 factorial. Now, how do you do that? Well, do you have your calculator? You can do 99 factorial, and it's crazy big. Right? It might even just say air. So just say air on most calculators, just air. It's just, remember, that's crazy big. So we would choose more than a billion on that. Remember, that's where the computers can't do it. There's just too many options, right? That's why that's why we can't just do all these circuit problems by looking at all the possibilities. There's too many. All right, 31. Complete graph, 12 vertices, total number of circuits. Well, yeah, so 12, it'd be 11 factorial, right? D, it's just n minus 1 factorial. That's a nice, easy question after all those other painful ones. There we go. Easy one there. Moving on. Let me remind you, in case you forgot or didn't put in your notes somewhere. Yeah, these should be easy for you. Let me just summarize over here. The brute force means listing every possibility, right? Too hard even for computers. But it is optimal, right? If you do it, you'll get the best answer. If you give the computer 800 years, it'll get the best answer because it'll look at every possible circuit. But it's not efficient. It's inefficient. It takes way too long. All other methods. So it's just like brute force and everything else. All other methods are not optimal. They will not give you the best answer. They're not guaranteed. That's why it doesn't work on the multiple choice to just add them up and take the lowest one. But they are efficient, at least for computers especially. They're hard for us, but computers can whip them out in seconds. So all other methods are not optimal. You won't get the best answer, but they're quick. You'll get a pretty good answer and you'll get it fast. That's what UPS and FedEx want, need, use. So brute force, perfect answer, but it takes forever. So let's go to question 32. Brute force is, they use the word approximate. Not optimal, it means approximate. Let me write that word for you. Right? If something's not optimal, then it's close. It's approximate. So when they say brute force is not approximate, it's optimal. And it's efficient. It's inefficient. It's C. Were there a lot of C's? I think every answer I circle is a C. Optimal, inefficient. That's brute force. Optimal, not efficient. 33. Nearest neighbor, cheapest link. These are going to be the same. In all the other methods are what? Approximate, but efficient. D. Approximate. They're not optimal. They're approximate, but they're efficient. And B. They moved them around on 34. It's the same answer on both of them. All the other methods are approximate and efficient. They're not exactly right. They're only approximate. approximate, and they're efficient. Is that okay? Those should be free points, right? Have that in your 3x5 card. Get your free points on that. Okay, here we go again. Same thing, decreasing time. Like I said, all the other algorithms, even the chapter 8 ones, all the other ones are approximate and efficient. That was C, right? I'm not messing you up, right? Isn't that what it was? That one was C. It's always C. Approximate and efficient. All the other algorithms, except for brute force. Brute force is the exact one that takes forever. Critical path, same thing. Approximate, efficient. None of them are exact. They don't guarantee the best answer, but they're efficient. Computers can crank them out quickly. All right, 23. Project consists of all independent tasks. If we schedule project 7 processors, here's that formula I gave you, right? N minus 1 over 3N, the air. You know, I just gave you that right for the practice exam. There's that formula. How do you know? It says independent, and it tells you 7 processors. That's N. So you take that 7 and you put it in. So you get 7 minus 1 over 3 times 7, 6 over 21. Somebody have a calculator? What is 6 divided by 21?
0.28.
0.28, so 28%. I don't see 28%. So is it none of the above? Is that E? 23 is E, none of the above. Should be 28%. Does that make sense on that? Will you be able to recognize that? It's independent tasks and then error percentage thing. N minus 1 over 3N. So those are the kind of weird little questions, right? Good on those? So you have all those formulas down, right? So you got the N minus 1 over 3N. You got the stuff about the algorithms, all the others, you know. And then you've also got these two formulas. N minus 1 factorial for circuits, N times N minus 1 over 2 for edges. They didn't ask an edge question, but they could on the real test tomorrow. I don't even remember, but it could be. So make sure you have those two formulas. We also had an error formula that said time minus optimal over optimal. Make sure you have that formula also. You know, you might wonder, well, we have 2 error formulas. Right. This is always true for error. I mean, you can always do that if they give you that information. But see, on this one that spoke of error, it didn't tell us any times, optimal, regular, or any kind of times, did it? So I knew I couldn't use that formula, and I had to use this formula because all they gave me was the number of processors. Did everybody see the difference? So we had 2 kinds of error things. If they give you times and optimal times, then use that formula for error. Both are true. And if they say independent tasks and give you 7 processors, use that formula, or however many processors. No times here, right? So I can't even use the other formula. Is that good? Well, I should have made that bigger. It's got 3 processors. Okay, 3 processors, number 26. So I'm going to do processor 1, processor 2, processor 3. This is very much the way the real exam will be. You see, like, I've given you 1 with 2 processors, 1 with 3 processors that are just like alphabetical order, and then I'm giving you 1 with 2 processors that's decreasing time, and then 1 critical path, right? So be very, and then 1 with independent at the very end, huh? So, and then 1 where you had to draw your own diagram, right? That's almost exactly the way the real exam is. Just testing the different kinds of things we did. So, all right, so let's do this. So these you want to be careful. You know, what's happened to students in the past, you know, I try to give partial credit as I can. So on these, I will give partial credit. But if you mess up early, everything's just wrong. So you got to be kind of careful on these. You know, if you, the main thing is the arrow diagram. Pay attention. Like if you just add numbers wrong or something like that, I'm totally merciful, and I'll give you almost all the points. Just adding, you know, who cares? But if you mess up the you can't start a job before another job thing, that's kind of the main point. So that kind of loses almost all the points right away. So really pay attention to that arrow diagram. That's the main thing. So as long as you follow that, you'll be good. So this isn't even nearly as important. It's the arrow diagram. That's where I really penalize, because I think that's where the main concept is if you don't pay attention to the arrow diagram. All right, so here we go. So which are my options for starting? A, B, and C, huh? A, B, and C, right? Because they come off the start, don't they? They come right off the start. Now, yeah, like what if they told me? Here's the kind of mistakes I've seen in the past. Let me just say this to make sure you know it. What if they told me for whatever reason, priority was I don't know. Priority was D, F, G, whatever. Let's just say that. I've had students start these and right away look at the priority list and go, okay, I got to start with D. And they'll put a D down here. That's just a 0 on that problem because they're not understanding that the arrow diagram is the main thing, right? So y'all getting that? That's the main thing. The priority list is secondary, right? The arrow, no matter, I wouldn't even look at the priority list at first. Don't even look at, don't let it confuse you. It's the arrow diagram really that rules. So again, go back there. So from the start, you go to A, B, or C. Okay, so I have options, A, B, or C. How do I know which one I'm going to choose? Well, this one, now I do go to my priority list. When I have options, they're saying go alphabetical. So do A before B. Don't do times. In a minute, they'll tell me times, right? They'll say higher numbers. But this one says just go alphabetical. When you have choices, just go alphabetical. Oh, okay. So I'll do A first. A's first in the alphabet. So A will take 8 hours. What about processor 2? Well, he'll do B. And I don't have time to write in the tick marks and everything, but you should. And then make it easier for you. C is a 9-hour job. So there's C. He goes out to 9 hours, right? They'll start with A, B, and C. Good. Now, where do you go next? What's the first processor done with the job? Who's done with the job first? B, processor 2 with the B, right? So the B job is done. We good to there? So let me just say, I know we're running out of time. Let me just say this is the kind of, so that's a good start. But here's where, like, if you stumble right now, I could only give a couple points. Because here's the kind of mistakes. I'll see people go, okay, D next. No. So they're just not getting the arrow diagram at that point, right? Why? Why can't we do D next? Because you can't do D until A and B are finished. You cannot do, you really have to pay attention to that arrow diagram. You may not start D until both A and B are done. You see? So at 5 hours right here, I'm right here at 5 hours right now, A's still being worked on up to 8 hours. A's not done. So you can't start job D, right? Does everybody see that? Well, what about E? Can I start job E? Just pop an E in there. No. Job E can't be started until C's done first, and C's being worked on up to 9 hours. So there's nothing available. It's got to be idle, huh? Idle. Does that make sense? It has to be. So everybody good? I don't want to have to take off points on that. So that's crucial. You can't, just because somebody's available doesn't mean there's a job available for them. There's not. There's no job available. So go up to 8 hours. Now at 8 hours, job A is done. Job B has already been done. C's not done yet, but A and B are done. Now, who goes first? Processor 1. What job's available? D. Now D is available. Only D. So give him D. It's a 7-hour job. Take him out to 15. 8 plus 7 is 15, right? Okay. What's processor 2 going to do? More idle time. Nothing's available. Well, maybe, though. Up to 9. Stop at 9. At 9, whenever you do idle time, you just do idle up to the next finished job. Because things change when a new job is finished, right? So only go up to 9. Don't go all the way to the 15. Go up to the 9. That's when the C job is done. Cross off the C. Both these guys are ready for a job. Which job's available? D's being worked on right now. D's being worked on by processor 1. So E's available, huh? Yeah, E. And processor 2 will go first because he's higher than processor 3. So he'll get job E, which is a 6-hour job. Where are we at? 9 add 6, 15, same place. Right? That was 9 add 6, 15, he's a 6-hour job. So then what's this guy gonna do down here? Idle time. There's no job available for him. So then at 15 hours, both these are done. What's available? F and G. This guy gets F first, 6-hour, 21. He gets G, 2-hour job. We're pretty much done at that point. There we go. This guy's idle all the rest of the way. This guy's idle to here. We're done. I mean, I don't have all the numbers, but that's basically it. Does that make sense? So the main thing is watching out not to give a job when that job's not ready to be given. Just because somebody's available doesn't mean they have a job for them. They could be idle. Is that good? So if you just watch out for that, you'll be good on that. Well, we're over time. We need to stop. So you have the answers for these. So you can check